Hello, everyone. It seems that we are live for this new webinar about the Data Engineering Manifesto. Thanks all for joining. I hope this is going to be useful for you. But before we dive into the content, let's first introduce our guest of today. Well, guest as a partner and CTO of Data Minded, I'd like to introduce Pascal Knapen. Pascal, can you say a few words about yourself?
Sure. Like Chris already mentioned, I'm Pascal Knapen. I'm a CTO of Data Minded. That means that I help our company with shaping the technical vision within our company.
Yeah.
And first and foremost, I'm a data engineer.
Yeah. All right. Cool. And well, for those of you who don't know me yet, I'm Chris. I'm the CEO at Data Minded. So that means in practice that I used to be a data engineer and now I make mainly slides. But no, in all seriousness, who is Data Minded if you don't know us yet? So we help, we're a consultancy, we're a data engineering agency. We help other companies to build out their data platforms, their cloud native solutions, their analytics pipelines, all of these things. Most of our work is consulting. We also have a product offering out there with Datafy. So if you haven't heard about Datafy yet, check it out. It's on get.datafy.cloud. And we also are shaping a Data Minded Academy where we aim to have some announcements soon, because the purpose of the academy is to train everybody who wants to be a data engineer to become a data engineer. I'm going to quickly check if the sound is okay, if video is okay. You guys, can you let me know in the chat if you all hear me well, if everything is clear, or if there are some technical issues, then let me know. All fine. All right, awesome. Thanks. Then let's start with a survey actually before we share our content. So I created a Mentimeter link. I'll post a link in the chat, and then I'll also open the Mentimeter slide to ask you a few questions first about what do you think data engineering is, and how do you look at it before we share our data engineering manifesto. I'll put the link in the slides and in the chat. Here we go. And I'll also open the screen here. So there's a few questions, right? To begin with, rating the following statements. If you don't find the link, you can also go to menti.com and then type in the code you see above. So there's 4 statements here. Do you think data engineering is well understood in your organization? Do you consistently apply data engineering best practices in your organization? And I know even a Data Minded, we're not perfect, right? So I'm not expecting a perfect answer there, but at least you try to. Do you see data engineering as a key aspect of your success, or because sometimes you can also just see data engineering as necessary plumbing that needs to be done? Do you also want to invest more in data engineering skills in the coming months? Just to get an idea of where you are. Of course, this is not a scientific study because it's kind of self-selecting survey here, because people who are interested in the data engineering manifesto are probably more mature in their journey, right? If you don't know what data engineering is, you're probably not here. I see the first results coming in. So data engineering is well understood. It's too, like some of you know not at all, have no clue. Well, not you, but your organization. And some of you are like, yes, our organization is quite mature here. About applying data engineering, it's a bit neither agree nor disagree, so that's interesting. You do see engineering as a key part of your success, most of you. That's good. Some of you don't. And you want to invest more in data engineering, right? So in the coming months, that's always good to hear.
Well, Chris, I do think it's interesting, the first part, right? Because this manifesto, which we're going to talk about, it's exactly about making it clear what we think data engineering is about and the things we think is important in data engineering.
Absolutely, because that's also the reason why we're doing this webinar, right? There's a lot of confusion about what data engineering is supposed to be, because it's still relatively new, I guess, although we've been doing it for 7 years now, but still it's relatively new. I also think that in general, more and more organizations are investing more in data. They've had their first data science use cases live or their first data science models built, and now they need to productionize it. And it's like, ooh, now we're stuck in the plumbing, if you will. So now we see an emphasis from data science more to engineering. Of course, data science is super important still, but there's more effort, more emphasis on engineering as well, right? So yeah, this is already helpful. Thanks. We have one next question before we go into the actual content, and it's more of a free-form question. So if you would describe data engineering, what would you say data engineering is in your own words? Or if you have to explain it to a colleague or to your manager or to your mother, even if you will, like what is data engineering in your words? We'll wait for a bit until the first answers pop up. I'm curious to see, by the way, if the answers that they're going to give here, if it's going to be remotely resemble the manifesto that we share, because if it's completely different, then it's like, oh, there's a lot of work to be done. Enable value creation from data, internally and externally. I like that already, because it focuses on the enabling part. That also comes back in the manifesto, right? It's about enabling other people for sure. Pipeline streaming, yes. Putting models in production is definitely part of it. Make data available for decision making, yep. Making sure the data is in the right place at the right time to allow the company to extract value from it. Bringing data fast and consistently to the teams who need to analyze it. Yeah, so there are some patterns here, right? There's a few of the things coming back. I'm going to scroll down. Getting data from A to B by integrating multiple systems. B is mostly the data scientist. That is true, but that hasn't always been true, right? Because like 10 years ago when we were still working somewhere else before data minded, a lot of the data engineering work would go into building dashboards or providing the BI specialists with the right data to build dashboards, right? Designing data pipelines in order to take care, to take data from across different sources into a common place where it is usable by data scientists and other use cases. Yeah, again, so we do see some patterns coming back here, right? Provide data for different sources to a data scientist, putting data available to the data users, process of making data speak to business users, creation of a data product, that I like. Yeah, that's a new thing. Data governance question mark, should we be doing it? Yes, we all should be doing it. Doing stuff behind the scenes, ensuring others can create value from data. Oh, there's a lot of answers here. Setting up architectures for data storage and sharing, integrating misaligned IT systems, the misaligned, I like the misaligned, yeah, with business. Domain which focuses on providing storing and processing data. Sorry, you want to say something?
We should do this more often. If we ever need quotes to put on our website, just organize a webinar and let people enter these things. It's great.
What do you think we do here? These things. Collecting clean and correct data in accessible data warehouses, organizing data that transforms data into your business context, creating scalable, performant, and sustainable ETL processes to support business data products and get technical stuff out of the way of value creation. Yeah. One thing I do notice here, and I wonder what your opinion on this is that there is a lot of, there seems to be a hard boundary between what a data engineer does and what a data scientist does. Like, we provide the data in a clean way, we provide the ETL, we do all the infra boring stuff, so that the data scientists can do their work. Well, actually, I don't know what your opinion is on that. How do you look at the data engineering, data science?
We'll get to that later on. Okay. So it's part of what's also covered in the manifesto. I think we can cover it there. We do see this, and it's not that I don't disagree with it. I think it's a very strong statement. I do think the data engineer is there to enable different data profiles. But it doesn't necessarily mean that data engineers have to do like all the ETLing themselves, right? I think it's a lot about enabling other people as well.
Yeah, self-service comes back there. Like if you can help more people to do in self-service their own thing without needing you, that's always a win, I think.
Oh, absolutely.
All right, cool. Thanks for the great input here. Well, let's switch to our thing, right? Because you're all here to hear from us and not to have some random chat. So let's see. Here are the slides. Sorry, I lost them for a bit. So let's go over the 10 guiding principles of our data engineering manifesto. Well, I learned from Pascal that I can't count.
Yes, indeed. There's only 9. Like Chris, there's one principle where you are always right. Like we canceled it and we went back to 9.
The most important principle.
So there were always 9, so I don't know how you get to 10.
Yeah, I don't know either. I can't count.
Off by 1 errors is one of the most common, right?
It is one.
three difficult things.
Indeed, off by one. What are the others? It's
exactly one, semantics and caching validation.
yes, exactly.
And naming things. So there's actually four, but
Yeah. It's another off by one error. Anyway, let's dive in because we're digressing a bit. Number one, we are software engineers.
I'm extremely passionate about this one, and I think it's mainly because we are still, as data engineers, we're still software engineers. Like if we're writing pipelines or we're building data services or any of these things, we're still writing code.
Yeah.
Like we're still doing software engineering. And because of that, I think it's very important that we just don't ignore everything that's happening in the software engineering space.
Yeah.
If I see where we've come in the last 10 years and all the trends that have come from like big waterfall designs to like all these agile methodologies, everything from testing, where all the testing things have gone through, everything from continuous integration to continuous deployment, continuous delivery, A/B testing, all these things. We shouldn't just ignore them because we call it a new field. It's not because we call it data engineering that we should throw away everything that's related to software engineering. And I think we should even go further. We should also look at the trends that are still currently happening in software engineering.
No, absolutely. And I think, by the way, a great way to predict the future for data engineering is just look at what software engineers were doing 5 to 10 years ago. So they were working on domain-driven design since 2006. Now all the data mesh thing is like the new hype since last year. And data engineering is about building a data mesh. Well, software engineers have been at least thinking about those principles for at least a decade, right?
But you see it, you see it now more and more, right? Like microservices in application development were really hot like a couple of years ago. Like I think it's still hot, but it's like hot and cold, right?
Passed the peak of the hype cycle.
No, absolutely. But you see other things as well, like this hexagonal design you see coming up, evolutionary architecture. All these things are just as relevant in software engineering as they are in data engineering.
Exactly. And obviously, I fully agree with everything that's said here. But no, we are indeed passionate about that. And this is not about being right or wrong, but I think going into a data engineering project with the mindset of a software engineer already gets you there half of the way.
No, absolutely.
All right, the second one, which also came back in the answers, was data as a product. What do you mean with data as a product?
That is a very good question. No, it's again like if we take the previous one where we say we're software engineers, like if we see the trends that have gone like to application development. When you build an application, you're looking at like who is using my data or who's using my application, how are they using my application, why? To make the user experience better, to get more value for the people who are actually using it. I think for a long time in data engineering, we were just dumping operational databases into a data lake, copying data just directly into a data warehouse. There was no thinking about like how people were actually going to use it. And I think that's all shifting. So we definitely see a shift where we're more conscious about like what data do we actually want to provide to an organization, when do we want to provide it, reliability, when are we rebuilding it? When are we refreshing it? So again, all these principles you see in application development are slowly moving into the data space. And for me, it's only for the best, right? Because if you're just dumping data, it has a cost, right? You have to maintain the pipelines. You have to pay for the storage cost.
There's a lot of hidden costs, right?
There's a lot of hidden costs, and there has to be some return of investment, right?
Absolutely. And I think this is a relatively new trend that we see to start treat dating as a product, and not just for a very long time it was like data as an exhaust. Like, okay, you have a process and it exhausts data, so you capture the exhaust like the pipe of a car, if you will, or the exhaust of a car, and then you do something with it. And that is actually, how do you say, well, an immature way of thinking is maybe put too negative, but I think you can improve by treating data as a product that you deliver to the rest of the organization instead of an exhaust, right?
Absolutely, and it's very funny because it's also about the metrics that you're going to capture, right? I think like if I look back at the older systems, typically if you had a data lake, what would you measure? You would measure the amount of terabytes or petabytes you would have in your data lake, because that
brag about it.
Yeah, because that was like a bragging right. Like I have 7 petabytes in my data lake, but they weren't talking about usage, right? I think there's a fundamental shift happening to say like, hey, storing this data and bringing this data to your customer has a cost, and we have to be aware like, is this actually bringing value to your organization, or is it just a sunken cost?
Yeah, and I also think that's where a lot of the, I don't want to make this a bash on Hadoop session, but I think that's where a lot of the Hadoop implementations fail, right? Hadoop as a technology was quite complex, but I mean, once you got it, you got it.
Yeah.
But a lot of the focus in many of these Hadoop implementations was focused on ingest everything into a data lake and we'll figure it out later. I think as a counter movement to the very strict traditional data warehouse technique, like let's model everything for 2 years and then publish it, that was also not the way. And now I think like treating data as a product is maybe in between those two extremes.
Oh, absolutely.
And it's a more healthy approach to how to treat your data. Yeah. All right, the next one, enabling, I saw that coming back a few times in the answers as well. So we enable by providing self-service solutions. There's a lot of big words in one sentence.
It's a lot of big words in a single sentence. So here I perhaps want to go back to like this entire Hadoop landscape, right?
Yeah,
if you look at like the history of data engineers, like anybody who could like interpret this monstrous architecture that Hadoop in the end put in place, and you could just make sure something runs on top of that ecosystem, you were a master data engineer, right? If you could just make something run in that ecosystem, right, you could probably like get the badge data engineer. I think like with all the evolutions that have happened, like the trends have shifted, right? Like I think now the role of a data engineer is more like enabling the organization, right? It's like it might be part of like building data pipelines or building complex data pipelines, but I think like the very simpler things you should enable within your organization. Provide self-service tools so people can build materialized views by themselves, for example.
Yeah, absolutely.
Very simple things. We should enable the organization. We shouldn't become a bottleneck within this area.
Yeah, no, the self-service part is important also because just if you look at the market, I mean, and it's true for us as for our clients as for anybody else in there. If you look at the market, one of the main bottlenecks in any data project is just the lack of data engineers, right? Let's be honest. And I'm not trying to sell anything here because very often they come to us and we're like, yeah, we're fully booked as well. So like, oh, what can you do? So and that has been true for a couple of years. I think that will be true for years to come. So if you're a data engineer listening, you're in a very good spot. Like you can probably choose where you want to work. That's just the way the market is. But if you're on the other side of the equation, you need to build a project. Always try to, the more self-service you can deliver in your project or in your platform or your whatever, the less of a bottleneck the data engineer will become, right? So and we truly believe, by the way, some data engineers can be very elitist about like, no. You need to be a Scala expert and know performance tuning and blah, blah, blah. Otherwise, you can't build this pipeline, which might be true for some use cases. But let's be honest, a lot of use cases, honestly, that's just not true anymore. Like cloud takes away a lot of the complexity. Most of the pipelines run just as well in Python or in DBT with SQL or whatever than it is in Scala or Rust or Golang, whatever.
And it's two things, right? You don't want to become like this bottleneck in your organization. That's one part. There are always not enough data engineers within your organization. But it's looking at it as like I wouldn't be motivated like building a materialized view like a very simple stuff. Well, I'm not saying like materialized views are always simple, right? You can have very complex materialized views, but a very simple use case, it wouldn't make my like technically I wouldn't really be challenged in doing this 10 times, 20 times, 30 times. Like I wouldn't really feel like I'm bringing real value if I'm doing the same job over and over and over again, right? Exactly. You then want to build tools that, especially for those common use cases, that make it easy for other people to do that, enable those.
And that's a mental shift. That's really, it's not about technology, it's really a mental shift. Like I'm here to serve other people, I'm here to help, I'm here to enable. And if they can be successful without me, happy days. And again, as a data engineer, don't worry about your job. There's like a million things you can still do, which are higher up the food chain, if you will. They're more fun.
But it can be hard, right?
It is super hard.
Because often there's pressure to deliver, and it's about taking this step back and saying like, hey, how can I make sure that I become a bonus multiplier instead of like, because you can probably the first time you can do it faster. It takes a lot more time to build this in self-service than to just do it the first time. Right?
Yeah. No, absolutely. It's a mind shift.
But it doesn't scale, right?
Yeah. No, indeed. Yeah. Right. So Another very opinionated statement here. We embrace cloud and managed services.
Well, I don't think it's the most, but I don't think it's the most like challenging one to explain. If I'm talking about like providing self-service things, for me, doesn't this make sense, right? The more tools you're building, the more things you are providing to other people in the organization. You don't want to be continuously looking at like, hey, is this thing still working? Is this database still running? You actually want, if these services are available in cloud providers, use them, right?
Yeah.
I think the biggest example is like, if you have a Kubernetes cluster running, it's very easy to get like a Postgres database running there. But getting it running the first time, it's not the hard part, right? It's the day two, right?
Yes.
When you have to operate it and you need to take backups and you need to recover and you need to update. And it's all these things that you don't want to be busy with, right? You want to be focused as a data engineer also in providing services to other people, not being stuck in operational things.
Yeah, indeed, that adds very low business value in the end, right? It is, you need to have a reliable, scalable database, but the more time you need to spend maintaining that database, that's all time that you're not spending serving your internal clients, building business insights, building common understanding. And this is something, why I said it's a bit controversial. I think most data engineers, they all adopt cloud. Because, well, it's just, we all agree. Is there anybody still in the call? Let me know. Is there anybody still wants to do things on premise? The cloud makes it so much easier for 99.99% of the use cases, so there's a no-brainer. But we do see engineers sometimes stuck in we want to build everything ourselves because it is fun to build.
It is a lot of fun. It is a lot of fun to build, right? And it's fun and it's no fun, right? It's fun to build, it's not fun to maintain.
That is true. And that brings me, and maybe it's a bit besides the point, but I don't want to mention, it brings me to this very skewed notion of we have our smart engineers building, and then we throw it over the fence to our lesser engineers for operations. That's not true. Operations is the hardest part. So throwing it over the fence to operations is not a good idea. The entire DevOps, you build it, you run it.
Indeed.
Super important. If you've been called out of your bed a few times at 3 a.m., you will start to feel less appetite to run your own Postgres database, right?
Yes. No, indeed. And there are exceptions, right? There's always exceptions to the rule. But I think like if we're building something, the first thing we typically look like, hey, I need a graph database. Okay, what can I get as a service, right? It's not the first thing that I'm thinking like, hey, how am I going to run this graph database somewhere myself and on my laptop, or how am I going to deploy this? No, well, what's available and what can I get out of the box?
Absolutely. All right, the next one, we're over halfway now with this one.
If you talk about controversial items, way more controversial.
Well, to me, it's a given, actually. To me, it's a given that batch processing is easier than stream, but we see a lot of projects that could have been a batch project that end up being a stream project.
No, exactly, and if you ask me purely as an engineer, what makes what captures my interest? If I can choose a project, give me a streaming project, right? I'm technically way more challenged by doing complex streaming, managing in-memory state migrations, fallbacks, replayability. These are all.
It's a lot of fun.
It's a lot of technical fun challenges to solve, right? It's very fun. It's exciting because it is challenging, but it's like you're saying. Like often we see there's limited value. We had it at one customer. They had built like a very complex streaming pipeline that was crashing continuously, and then we basically went to talk to the users and said like, hey, what do you actually need? And they said like, hey, we're pulling like once a month we're building this dashboard and we're sharing this with our customers. And they said like, well, why did you build it real time? Yeah, the engineers decided like real time would be the future, so they went real time.
Yeah, and it's an important lesson. Usually when you've done this a few times, you know this, but we see companies make a lot of mistakes again. This is big companies with a lot of strong engineers. So it's not about are you good enough as an engineer to do this, yes or no. It's about where you put your effort and where you put the emphasis, right? and I've really seen hundreds of thousands of euros, if not millions of euros, wasted on complex streaming architectures that could have been like replaced by a batch job that you can build in 2 weeks or something. Yeah. So definitely, it's maybe when the streaming technology matures over the coming years, that will change our mind on this. And but for now, we really believe this statement is true.
And I am keeping a tab on that. But remember, recently we had a call with Confluent, like the people behind Kafka, and we honestly asked them, like, hey, your KSQL, is it production ready graded? Like, can you actually use it in production? And like, these are the makers, right? The people behind Kafka itself. And they basically said, like, that's how we might market it, but it's still early days to actually run it in production.
And I mean, just to state the obvious, that doesn't mean you should never do streaming. There's a lot of valuable streaming use cases out there when real time is important, and there you should put your effort into making this happen, right? But just don't turn your batch problem into a streaming problem.
No, and the second thing is coming back to the previous one. It's way harder also to put it in self-service, right?
Oh, absolutely.
Because stream processing, you have this extra dimension of time you have to continuously take in mind. And I know, like, only when the Beam model came, it solved a lot of these, or at least it explained how you could solve all these problems of late arriving facts and all these other things.
Yeah, so if you want to know more about it, indeed, the Apache Beam project is one of those streaming frameworks. One of them, they really set the scene there. So look at their presentations to understand all the complexities that go behind streaming. Next, we aim for simplicity through consistency.
It's kind of a follow-up of the previous one, right? It's all about keeping things simple and as simple as possible, right? And I do think, like, look at data engineers, right? There's a lot of demand of data engineers, and you're probably going to work for how many years for a certain company? 2 years, 3 years, 5 years, 6 years?
It's a very dynamic market.
It depends, like, how good the company is, like how challenged you are at that company. So as an engineer, it's very often to see, like, ooh, here's some new bling, and I want to play with this new technology. But I think it's very important to put actually these companies first, right? Because if the more consistency you put in, like, the technology you use, the more easy it will be for those companies to maintain. But also, if they ever want to migrate to a new technology, it's way easier to move something that's done consistently in one technology to move it to another consistency instead of having to migrate to, like, 10 different solutions to something new.
Absolutely. And this is especially true if you're like us, if you're a consultant. Like, success is not, can you as a consultant build it for the company? The success is when you leave and the company takes over, can they be successful without you, right? And if we're really being honest, we also had cases where when we left, the solution we built was too complex for an organization to keep alive.
Oh, absolutely.
Yeah, that's also one of the reasons why we put that here, right? So we're definitely not perfect there. But it's something to really keep in mind, like the people who will operate the solution, will they be successful with it, yes or no?
And it's one of the reasons we put this in here, right?
Yeah, absolutely.
This manifesto is not only to sell, like, what we think data engineers is, but also, like, internal to reflect on when we're building something and delivering things to clients.
Exactly, and how we approach these projects, right? All right, we're already at 7, talking about controversy. Although if there's an audience of data engineers here, I think they agree. If there's an audience of data scientists here, they might not agree. But notebooks are for research, not for development. Why not?
Well, I could quote, I don't know how many people, but if you ever had the chance, like Joel Gross on Jupyter Conference once did an amazing presentation, like why I don't like notebooks, or I don't like notebooks, right? And that at JupyterCon, like it was quite controversial.
Very brave.
But it's an amazing slide deck that talks about everything he thinks that's wrong with notebooks. I love that presentation, but on the other side, I don't completely agree with it.
Okay.
I agree with the technical parts, right? What's technically challenging about notebooks, but I do think notebooks bring a lot of value because they provide a very short feedback loop when exploring your data.
Yeah.
So you're looking at your data, you're building histograms, you get immediately feedback like what's happening behind the scenes, how does my data look like? Very easy to do some graphing on top of your data to really get a gist of like, how does this look like? Perhaps run some queries like, how does this behave? But that's where it stops, right? That's that feedback loop, and that's good. But then if you start about talking about like actually implementing a data pipeline, you want a different kind of feedback loop, right? You want to go quickly to production. You want to have tests to be able to test locally. And I think there is the difference where I don't think that notebooks make it very easy to quickly iterate to production, to quickly write or do testing, do debugging. I know Jupyter just recently added a debugger to it, but it's like we're talking about like a month ago or 2 months ago, right? It's very recent, and I think you can do a lot of these things in notebooks, but it's just like you can do a lot of things in VI as well, right?
Yeah, indeed. But I do think, just to challenge you a bit there, Netflix seems to disagree with us because they do put their notebooks in production.
Well, it's all about you can, right? But how many companies can say that they have the data maturity of a Netflix?
Yeah,
right.
Not a lot, right?
It's so I don't think it's necessarily a bad tool, but you have to have really strong practices and really strong profiles to get it right.
And that's exactly what they did, right? So they built frameworks around this. They built an entire process around this so that you can industrialize your notebooks. And if you do it that way, all the more power to you, right?
Absolutely.
It's just, in reality, we don't see any company doing it that way. It's just hacking your notebook and at the end of the day, schedule.
I think that's mainly why we also, I think we've all seen a lot of dragons, or inherited notebook dragons, and then I'm hesitant to.
And the other way around is also true. I can also write very ugly code in an IDE, right? You know I can. But it's about selecting the tool that incentivizes you to do it.
Absolutely.
To do it the right way.
But also like all these modern IDEs are, again, like if you go back to the first principle, right? It's having a linter.
Yeah.
Something like that.
Simple things like that. Yeah.
Having a debugger. I know, right? A lot of these tools are coming to things like Jupyter. Having refactoring tools to like just say like, hey, we need this variable like across all my files just at once. It's like all these little functionalities that just makes your life a whole lot easier.
Yeah. All right, cool. By the way, if you don't agree with any of this, I think you can still in the chat let me know what you think. There will also be questions after, so you can pose some questions, right? We don't say we have the truth in us. We just, from our experience, this is what we've learned to be true. So I hope it's helpful for you. Data scientists are our colleagues, not our mortal enemies. So maybe let's ask it this way: why would somebody think that they are our mortal enemies?
It's a little bit of an exaggeration, right? This statement, it's a little to capture the attention. No, we do sometimes see like a dysfunctional marriage between data scientists and data engineers, and it's often on one side there's this overlap in technology that they use, but I think that's often like we also get into the situation where a data scientist and a data engineer gets into like the same setup that we used to have with dev and ops.
Yeah,
right?
yes.
Like
yes.
where a developer would write code and the operations people would be responsible for like deploying it in production and running it in production. And that's something we also sometimes see in a relationship with data engineers. Data engineers write notebook code, and then a data engineer is
data scientists write notebook code, and a data engineer is responsible for industrializing it.
No, absolutely. And I think that relationship is wrong, right? I think like data engineers should enable data scientists to put their own things into production.
The entire ML ops movement.
But it's the same as this DevOps mentality that originated there. I think it's exactly the same, right?
Yeah, because if you do this throw over the wall mentality, like a data scientist, they're hired to build insights, to build models, to build cool stuff. So they optimize for that. Build a lot of fancy, complex models with very complex data. Data engineers are incentivized to build stable things that run in production. And like that mismatch by a lot of new innovation coming at you, and you get all the flack whenever shit hits the fan, if you will. Like that. Like you're one team, you're solving the same problem, different aspects of the same problem. So indeed, that the throwing over the fence mentality we see that too often, and we definitely recommend organizations to embrace more MLOps principles, right?
No, and perhaps something to add here. It's recently you see a lot of like these blogs popping up, like, hey, data science is going to disappear, or data engineering is going to disappear.
The doomsday blogs.
No, but there's now a lot of things to do, right? Especially with AutoML coming, and people are a lot of questions. And I often reflect on that, and I look back at other industries, right? It's not that tools that were introduced like Wix to build websites that we suddenly don't have
website developers.
We don't have web developers anymore, right? The only thing that happened is we made that industry more mature, right?
Yeah, exactly.
And I think like the same for data engineering and data science.
Yeah.
The impact is going to be is that the industry is going to get more mature. Because of it.
And I think for data scientists, the same rule applies when you said like, hey, as a data engineer, you don't want to deploy your 100 materialized view. As a data scientist, you don't want to build your 100 model that could have been an AutoML model, right? You want to focus 80% of the models, if they can be trained by AutoML, happy days. So you can focus all your brain power on the 20% of the models that are actually hard. So it's a no-brainer if you think about it, but still we don't see it always in reality, right? We come to our last principle because we have 9 principles. SQL is the lowest common denominator. That's an interesting one.
Yeah, this one requires, I guess, some explanation, right?
Yes.
Well, if we look at things like we talked about building services to enable other people within the organization, right? And if we look at them on the other side, like we look at flexibility, right? If you look at the really most flexible thing on a computer, it's a compiler, right?
Yes.
And everything you put on top of it, like what you take away, right? It's you take always a bit flexibility away the higher you go up the chain.
Yes.
And I think all the way at the top, like you have this extremely high level of abstractions. Like I would completely compare it like drag and drop tools, where personally I've worked enough with them to not be a fan of them. Yeah. So we tend to put like somewhere the bar in the middle, and I think in the middle we mean like, hey, SQL is as far as we go. I think the border we should take is there. If we give people SQL, that should be high enough. It's an abstraction that's so powerful and easy to use, or a lot of people are so used to using it that I think it's the right abstraction to put this boundary.
And I think, in my opinion, it's fair to ask of anyone that works in the data department that they should learn SQL, at least the basics of SQL. Yeah. They don't have to know like all the crazy stuff in a common table expression or complex windowing functions, but the basics of SQL, if you're working with data, should come naturally to you, right?
Oh, absolutely.
And there, maybe going back to what the other elephant in the room about drag and drop tools, there is definitely a place and a time for drag and drop tools. We just never seen them being industrialized very successfully.
I have this known example where I helped an organization move to like business really wanted to move towards drag and drop because they wanted to do all these things themselves, and so we enabled them to do this.
Yeah.
But what ended up is like they did it a couple of times, and then of course you have like exceptions, and then you need an engineer. But on the other side, like things were also changing on the other side, and business was not interested in keeping these things up and running. So then they actually threw the tools back to the engineers.
Which prefer not to drag and drop.
Yeah, and they don't want to do this. And then we had this entire use case where we had to rename, like, for every thing we got in, like had to rename columns, and like hundreds and hundreds of columns in each data set because they changed the naming schema. Like in code, this would be a for loop, right?
Yeah.
I remember really together with the team, like clicking for days to fix all of these mappings.
It just very often seems that drag and drop tools are the wrong level of abstraction for a lot of the data workloads, right?
I think it's a little bit too high.
Yeah.
I do think there are cases when it could make sense if you have something like.
Yeah.
In some cases, we typically put the boundary at SQL.
Yeah, and while SQL statements, if you've worked with them a bit, they can also tend to become very, very, very long. I tend to write very long SQL statements as well sometimes, but there are tools, and I'm going to be the fanboy again, but there are tools like DBT, I can't help it, but that modularize your SQL a bit more. It's just a tool, right? So it's not going to solve all your problems, but it's a tool to make your SQL a bit more structured, modular, tested, documented.
Absolutely. And you were talking about common table expressions, and you know, I'm a fan then when it comes to writing SQL. I do think indeed like tools like dbt emphasize on using things like common table expressions, like breaking up a big problem into smaller problems.
Yeah. Indeed.
And I think that's just very, very good practice. And you can then add testing of these things and go on.
All right, cool. Well, thanks, Pascal, for sharing the 9 principles of data engineering. And together they form the Data Engineering Manifest. We're going to switch back to the audience now to see what they think. So I propose we go back to Mentimeter and see, you can post your questions there. At the same time, I'll have a look at the chat to see if questions came in there. So here I'm going to, on Mentimeter, if you go to menti.com, you type in the code again, 23633229. Ask us any question. If you have remarks, if you disagree with something, let us know. I'll quickly check out the chat as well to see if something came out of that. Peter asked to lower the amplification of the microphone. Where does the data architect fit in? Yeah, sorry, Peter, I just read this now.
Is it, Peter, perhaps you should answer, it's me or Chris or both?
Both. Okay, yeah, well, we can't rewind now, but thanks, Peter. I'll speak more quietly. Maybe put the mic a bit more down. Yeah, okay. Nela asks, where does the data architect fit in? I don't know, Pascal, if you would like to answer that one.
Well, this was about principles, but I do think a data architect definitely has its place, right? But for me, it's the person that overviews like how you apply everything from distribution within your data or like within your organization. Like, what are the principles? Are you going to go for a centralized department? Are you going to go for like a data mesh approach? How do you organize? Like, what responsibilities do you lie with what tools? Where are for example, like what kind of governance do you want to apply on your data? What tooling would you be interested in using to do centralized governance, for example? So I think a lot of like these high level decisions are taken by the data architect and to enable actually other teams within your organizations. But I do think that's the responsibility of a data architect.
Yeah, absolutely. So I agree with you, by the way, but then when you say those are the responsibilities of a data architect, you're also saying, so it's not the responsibility of a data architect to be involved in individual data pipelines to decide how you build your jobs, or?
Well, you can as a data architect, I do think you have a role to decide like what kind of technologies you're going to adopt within your company. What we said before, right? You want to have some consistency within your organization.
Yes.
And you can, for example, say like, hey, these are the 3 technologies we're going to use within our organization. And that would be your role. But I don't think a data architect should be involved with the actual implementation of an individual data pipeline. Perhaps if it's a really complex one that has major impact on your organization as a whole, that he might play a role there. But overall, I see more like enabling everybody else, like enabling data engineers, enabling software engineers, enabling data scientists within your organization.
Yeah, no, absolutely. I fully agree. So there's definitely a room for a data architect. It's not like you need to turn everybody into a data engineer. But again, like this enabling function is even more true, as you said, for a data architect, right? They have to make sure that each individual team can be productive. And that like some overarching constraints are put in place. It sounds negative, but indeed, if you just let every team, here's your empty cloud account, just hack away in whichever tool and technology you like, and let me know when you publish something, then in reality, what you get after 2 years is that everybody's built more or less the same thing in a different technology. People have rotated your team 3 times over, and you're stuck with a mess.
Yeah, no, absolutely. And now also it's very hard to move people between departments, right? If somebody is interested in going to another department because he thinks there's an opportunity, he has to relearn everything again. So there's definitely
some constraints help. Constraints liberate.
yeah,
right?
lovely.
Okay, so we have about 10 questions, and for some reason, question 4 of 10 has popped up as the first one. So let's go over them. What about using notebooks for prototyping?
You want to take that one?
Well, it's an obvious. Well, at least to me, I don't know. Maybe you say something different, but it's an obvious one for me. Yes, I do notebooks for prototyping all the time. It's a great tool for prototyping. It's much easier to prototype in a notebook than it is in an IDE. It's just, I always take the comparison of a car factory, which is a dangerous comparison, I know, but you design your car prototype somewhere in a lab, and you just show what can be done with the prototype, and you show it to the world. Where you don't start producing hundreds of thousands of cars from your lab, right? You need a factory to produce hundreds of thousands of cars. It's the same with data prototypes. Just for you to run on some sample data, awesome. If you want to industrialize it, you need a factory.
Oh, absolutely. So I also
okay. Let's go to the next one. One in 12. So sorry, I'm a bit struggling with Menti here. Still missing out on a global strategy. Lots of problems can be avoided by a well-designed IT landscape where data is integrated in the daily operations of an IT team. What's your opinion on that? I think this comes back to the data product aspect. That I do agree. I'm not sure if you mean this. I do agree that if you consider data as a product from the beginning of your IT projects and you deliver data as a product, indeed you will avoid a lot of problems. And a well-designed IT landscape definitely helps. So that's obvious to agree with that. On the other hand, well, I don't see a lot of well-designed IT landscapes. I wish I could say differently, right? I don't want to bash on. Yeah.
But I think it comes back to what's the role of a data architect, right? What you're describing here is indeed like the role of a data architect is indeed like setting out a global strategy. It's always like if you look at greenfield scenarios, it's really easy, right? But if you look at a lot of companies, like it's mergers of different companies where different IT landscapes clash, and you don't easily move from, like, you can have this well-defined vision, but in the end there will be mergers, and you have to see like how these things will fit together in the long term and the short term.
Absolutely. Just for the sake of time, I'm going to quickly go to, because the number of questions keep increasing. So, how do you keep the data model consistent if every department or team builds their own self-service data products? That's a very interesting one. So I don't know if you want to go ahead with this or.
Well, the question here is like, what data model are you trying to keep consistent, right?
Exactly.
I don't believe there's a unified model within your organization that everybody should like aim towards. Like, there's no one model for the entire organization. No. I think every department or every unit should be responsible for providing their own data. And then it comes back to providing data products, right? This is the data I publish within my organization, and part of publishing a data product is the same like publishing an application or an API, right? You have to think about like consistency, like how do you make it consistent? Like you can't just continuously change your APIs, and I think it's the same with data.
To make this very concrete, we once worked for a company active in rail, and their operational department had a different definition of what a train was than their sales department. So for sales, a train was just, I sold a bunch of wagons to a client, and those wagons go from A to B, so that's a train. Well, if you ask operations teams, like, no, a train is a locomotive plus a bunch of wagons, and it can be for different clients. And you will never, ever be able to solve that, definitely not with technology. It's just about domain-driven design. Just be explicit about what you mean when you say train. And it's okay if operations says something else than sales, right? Just make it explicit. Next one is, where should the data engineer sit within an organization? Oh, very good one. In the same team as a data scientist, as a separate team in IT or other spaces like digital. I like that. Digital.
I can take that one, right? Well, I have my personal preference, right? I like well-focused teams that work towards a common business goal. So I like to put data scientists and data engineers together working for a common business unit and going there. If they then belong to a common IT organization and that's centralized, I don't care. It's like this vertical things on top of horizontal
matrix organizations.
Yeah, no, absolutely.
Yeah. No, indeed, but key to what you said there is make sure that there is one team who is able to deliver a business use case end to end. If you need a data scientist for that, and an engineer, and an analyst, and a designer, then that's all on the same team. Maybe the let's say the exception, or I mean the special case there. Very often you have some kind of data platform team or data infrastructure team who's responsible again for enabling all the other teams. And very often there's data engineers in that central team. But then you should really treat all the other teams as your customers. You can't be the bully that defines like this is how you do it or else go away. No, you serve your internal customers,
Absolutely.
if you will. Yeah. And indeed, whether they fit into IT or digital, just give the executive their titles. That doesn't matter.
And in the end, like you also see like more and more machine learning getting their way into data engineering, like automated data quality monitoring and these kind of things.
Absolutely.
So even there, like in the centralized team, you often have data scientists and data engineers sitting together.
Indeed. And the closer you can be together with business, the better, right? So if you can be within a marketing department to solve a marketing use case end to end, fully self-service, I think that's perfect, right? How do you apply the manifesto in a corporation with hundreds of spreadsheet files as data sources? Well, we love, but that's reality.
Yes.
So reality, like it's an important one. You can't come in as a data engineer and say, I want perfect data sources or else I won't build my pipeline. So you just have to accept that some data sources will live in Excel, maybe on a Google Drive or on a Dropbox or something, but just identify that as a source of technical debt and as a source of risk, and manage that. Try to move an organization away from that if you can, but also manage expectations. You can't. Excel is. I'm a big Excel fan. I think Excel is one of the most powerful tools out there, which also gets abused the most. But it's true, but so you can't avoid it. I don't think I've done a single project where we didn't load from Excel, right?
I have something else to add there.
Okay.
I really believe in and it's a very old, but like stone soup, right? I think go for a small victory and then make people exciting about it, right? Even if there's like you're making stone soup, right? It means like you have water with stones in there. You're telling everybody it's soup, right? And if people get excited about it, they will start adding to it. You can't. I don't believe in like big bang transformations. You have to start small, get people excited about it, show them the value that can be there, and get them incentivized to actually join on this journey.
Absolutely. And maybe one last thing to add is also, again, treating your data as a product. So whichever department delivers the Excel, well, they should start making a reflection, like, is this how we want to serve our data to the rest of the organization? Is that what we want? And maybe it's a short-term technical solution, but everybody agrees it's not a long-term solution, right? So, how do you see the relation between a data lake and a cloud data warehouse, Redshift, Snowflake? It's an implementation detail almost. Honestly, they were day and night different. A couple of years ago, they're coming more and more together, like what you can do in a data lake. Typically, what we do with a data lake is we put data in Parquet there and we register it in a meta store, right? It is almost as structured as a data warehouse, not as structured. But so these two worlds are coming together. I still think that a data lake is better suited for typical machine learning use cases, for more heavy lifting, while data warehouse is better suited for querying, reporting. But you can do querying and reporting on a data lake, and you can do ML and AI on a data warehouse. In the data mesh principle, they're just nodes in your architecture, right?
And it's becoming more blurry, especially with these lake house architectures of like Dremio and Databricks. It's becoming more fluid, but I do agree, like they're coming closer and closer together. I don't think they're there yet. I always think more as like the data lake where you store also all your historic data. It typically has a lower price point.
Yes.
To store your data there, but also all the entire multi-model things, right? In current data warehouses, the use case we're seeing now with a customer where they're analyzing sound fragments from the support desk, This is typically something you can't do in a data.
Well,
in a data
technically you
warehouse.
can store a blob in a data warehouse, but you don't want to go there.
Yes.
Right? Yeah. No, it's fair. For the sake of time, I'm going to do a few more, and then because I have some final questions or survey things, and then I want to wrap up at one to respect for your time. Are self-service products really that useful? Without knowing the data and what it represents, one cannot make an impactful decision, which would lead us back to data people handling all data requests. Well, self-service data products also means that you document your data, like the DATSIS principles of a data product. I don't know by heart, but it should be addressable, discoverable, addressable, structured. I'm not sure, but you need to document what you serve. Just like if I just create an API endpoint for people to consume and I don't share what's behind that API endpoint, it's completely useless. But if I document my API with like these are the request parameters, this is the information you're going to get back, this is the structure, then an API becomes useful. It's the same with a data product. So, and that's where data governance, data intelligence, data catalogs, metadata management is super critical.
No, I have not a lot to add there, because I think you covered exactly.
Right, let's quickly do one more and then switch. SQL is the lowest common denominator. I agree for a data team, but the experience with customers wanting to play and agreeing on learning SQL instead of having a drag and drop interface. I think in general, it's very hard to convince people when they have a strong opinion about something to change their mind, right?
Mm-hmm, yeah.
So if you want a drag and drop interface, or if your client wants a drag and drop interface, I would say let them have it. My personal advice, but it's up to you, is just don't make sure that you don't get burned on it. Mm-hmm. So and maybe put this positively, if they can in self-service maintain their own things in drag and drop, whatever they do in their domain or their department, mm-hmm. all the more power to them, right? If I were a data architect and I want to like depend other data products based on that, I would be a bit more skeptical. In general, I don't see a lot of resistance against learning SQL. So that is fine, but it's convincing somebody of like, hey, your tool of choice, we don't like that. It's the same discussion of Python versus R. If you love R, you will never be convinced of Python. And if you love Python, you will never be convinced of R. So yeah, let them have it. I would just make sure you put it in a bounded structure somehow. Mm-hmm. I don't know if that makes sense.
No, absolutely. Again, Chris, you covered everything, so not that much to add.
Then I have two more other slides on menti.com. Sorry, we couldn't go over all the questions, but if there is something interesting on the questions, we'll reply in a blog or something, and we'll share the blog afterwards. But so this, already 5 people rated this, so we're interested. We shared 9 principles here, the 9 data engineering principles. Like the question now is, can you rate those principles on 2 dimensions? 1, are you applying the principle? Are you actually doing it? And 2, should you be applying this principle? Like, do you realize, yes, it's important, but we're not doing it enough? So on the x-axis is principles that are well understood, that are quite mature, people are doing it. And on the y-axis, the more higher you go on the y-axis is like, we should invest in this more. So here, for instance, from the 5 results we already have, say we embrace cloud and managed services, so you want to invest more in that. You think that's important. While 3, we enable by providing self-service solutions. Let's say a little bit more convinced. At least one of you is not very convinced that you should be doing this.
It's perhaps also because it depends like where you put self-service and to whom, right?
Yeah.
If you look at AWS, for example, it's self-service on one side, but it's really mostly aimed at technical people, right?
It is.
And self-service can be a very wide spectrum.
The 2 ones here are also interesting. So 5 and 8, especially 8, in general, people agree like we should love the data scientists more. But there's one person who's really like, oh no, we're doing this and I hate it. We should not be doing it. They are our mortal enemies. So that one person is skewing the results a little bit, but that's fine. And then 5, some of you were in the middle about batch processing is easier than stream, but more in general, I do like this, that you tend to agree with this. Let's see the more contentious one, if you will, is 3 is a very, like self-service is spread out. Like there's quite a few of you who are not seeing the value of self-service, which is fine, right? It's spread out all over the map. 7 notebooks are for research is another controversial one, I guess, where you definitely should not, some of you think like we shouldn't be applying this principle. Data as a product, yeah, again, somebody got bitten by it, I think, or maybe they misunderstood the scale because it's a bit confusing in Menti, but in general, people agree that you should be treating data as a product more. That's good, it's a sign of maturity again. We are software engineers, yeah, these are all in the pack. Yeah, that's fine. Yeah, 3 is an interesting one. Okay. And with that, we're going to skip to the final question, basically just rating this webinar. So was it relevant for your daily work? Did you learn something? Did you learn a lot about data engineering? Were we being clear and helpful? Do you plan to apply the ideas that you learned in this webinar? And while the answers come in, with that, I would like to wrap up because we're like 1 minute over time. I apologize for that, but it was an interesting discussion and I liked all of your questions. So thank you very much. If you want to discuss this further, you know how to find us. Chris@dataminded.be or Pascal@dataminded.be. Just get in touch. I'm happy to have a discussion with you. Yeah, and I would say thank you, Pascal, for joining.
You're welcome.
We'll share the slides, we'll share the video afterwards. We'll also share the manifesto. I hope this was helpful to you. All right, guys, take care.
Cheers.
Bye. Stop.